Welcome to The Explainer. Today, we're going to talk about the hidden math that pretty much decides whether we succeed together or, well, fail apart. It's this underlying equation that affects everything, from simple games all the way up to the future of our entire society.
So here's what we've got lined up. We're going to start with a classic puzzle that shows how even smart, rational people can get trapped in a bad outcome. Then, we'll pull back and introduce a really powerful mathematical tool to help us find a better way. After that, we'll scale it all up to see how groups can achieve way more than just the sum of their parts. We'll add a crucial complication, and then finally bring it all home by applying this to maybe the biggest cooperation challenge of our time, the age of AI.
Okay, so to really get a handle on this cooperation equation, we first have to understand the problem it's trying to solve. And honestly, there's no better way to see that problem in action than through a simple, classic little game. I want you to imagine a situation where two people have to make a choice. But here's the catch. The smartest, most logical move for each person on their own actually leads to a worse outcome for both of them when you put it together. It's a paradox you see everywhere in life, and it kind of makes you wonder about our own nature, doesn't it? So, take a look at this table. This is the famous prisoner's dilemma, but let's just use coins to make it simple. The numbers are how many coins each player gets. If you and I both decide to cooperate, we both get 3 coins. Sounds pretty good, right? But if I decide to defect while you're still cooperating, I walk away with 5 coins and you get nothing. And if we both decide to defect, we each get just 1 measly coin. Every choice we make directly impacts the other person. And this is where it gets really tricky. The individually rational move is always to defect. Why? Well, because no matter what the other person does, defecting always gives you a slightly better personal outcome. But here's the trap. If both players follow that cold, hard logic, you both end up in the worst possible spot, with 1 coin each. The best outcome for everyone, the socially optimal one, requires you to trust that the other person is going to cooperate. It's a total paradox. So how do we get out of this trap? Well, we have to completely change our perspective. Instead of just looking at the game from our own selfish point of view, let's try taking a view from above and figure out what's truly best for the group as a whole. And that brings us to this really cool idea called social welfare, which we'll just call W. It's a simple but incredibly powerful concept. Instead of obsessing over our individual scores, we're going to create one single number that measures the total well-being for everybody involved. It's like asking which choice makes the entire pie biggest for all of us. And you won't believe how simple the formula is. For our coin game, we literally just add player A's coins and player B's coins together. That's it. But this tiny shift completely changes the goal of the game. We go from asking what's best for me to what's best for us. So when we actually apply this, the best move just jumps right off the page. Calculating the total welfare, W, shows that when we both cooperate, we get a total score of 6. That's the highest on the board. The selfish moves are stuck at 5, and that rational trap we fell into, it's a pathetic 2. From this new viewpoint, cooperation isn't just some nice, fuzzy idea, it's mathematically the best choice. Okay, so that view from above works great for 2 players. But what happens when we scale this up from a little game to, say, an entire society? This is where things get really, really interesting. You've definitely heard this phrase before, right? Well, it turns out it's not just some philosophical saying. It's a mathematical reality in cooperative systems. It's called synergy, and it means that when we work together, we don't just add our efforts, we actually multiply them. We can actually model this idea with a new welfare function, W equals K squared, where K is just the number of people cooperating. You can think of it like this. When you add a new person to a team, they don't just bring their own individual work. They create all these new connections and new possibilities with everyone else who's already there. The benefit isn't just 1 + 1, it's exponential. And just look at how this plays out with 4 people. If 1 person cooperates, the welfare is 1. If 2 cooperate, it jumps to 4. 3 gives you 9, and with all 4, you get a welfare of 16. Do you see how the total welfare just explodes upward as more people join in? That right there, that's the power of synergy. So here's the key takeaway. If those 4 people had just worked by themselves, their total contribution would have been a measly 4. But by cooperating, they generated a total welfare of 16. Cooperation didn't just add their efforts, it multiplied them, creating 4 times the value. That's the synergy engine firing on all cylinders. Okay, but it's not always that simple. There's a critical twist. Cooperation isn't always some magic bullet that works right from the start. Sometimes, it only works if you can get enough people on board, if you can reach a kind of critical mass.
This is something called the threshold effect, and it's a super important idea. It basically means that in a lot of real-world situations, having just a few cooperators can actually be worse than having none at all. Why? Because all their effort is basically wasted until the group hits that magic tipping point where things finally take off.
Now, check out this table. This is a much more realistic scenario. You can see how the total welfare goes up as more people join, but only up to a point. It actually peaks at 20 cooperators, and then it starts to decline. This is basically the too many cooks in the kitchen effect. Past a certain point, things like congestion or just bad communication mean that adding more people actually makes the whole group less effective. And once you start looking for these tipping points, you see them absolutely everywhere. Herd immunity only kicks in if enough people get vaccinated. A social network is totally useless until it has enough users. An open source project needs a critical mass of developers just to survive. In all these cases, success doesn't just depend on cooperation. It depends on reaching a specific threshold of people participating. So all of this, it brings us to our final section, and honestly, probably the most important application of this entire framework, the rise of artificial intelligence and what it means for our future. So how does all this math about coins and cooperators and tipping points relate to AI? Well, it turns out that the way we develop and roll out artificial intelligence is shaping up to be humanity's biggest, highest-stakes cooperation challenge ever. The principles we just talked about are going to decide whether this incredible technology lifts everybody up or creates divides we can't even imagine. So what's the danger here? In a nutshell, it's this. If only a handful of companies or countries get to control the most powerful AI systems, our total social welfare, that W we've been calculating, could end up being far, far lower than it could have been. It's the ultimate scenario where the whole becomes way less than the sum of its parts because a few people are creating a bottleneck for everyone else.
I mean, think about what that really means. When access to a technology this powerful isn't shared, we all lose. Innovation gets stuck because brilliant people can't get their hands on the best tools. The wealth gap could explode. We'd end up in a world where we've wasted the incredible potential of AI all because we couldn't pass this one big cooperation test. But, and this is the really powerful silver lining, the same tools creating this problem can also help us find the solution. We can actually use AI itself to model these complex social systems, to simulate all the different outcomes, and to pinpoint the exact tipping points we need to hit to create shared prosperity. We can literally calculate the best path forward.
And that leaves us with one final, crucial question. For what might be the first time in history, we have the tools to actually calculate our best possible future. We can model the synergy, find the tipping points, and design policies for the maximum good. The technology can literally show us the path. But choosing to walk down that path together, well, that's still up to us.